Hello everybody, here we are in Unit 2 of Geometry, solving out problem number 113, which is some algebra stuff, solving these systems of equations. Probably a variety of ways we can do these, right? We got linear combination, we got substitution, we got just throw some random numbers on the paper and see if they work. I prefer the first two methods personally. They always seem to work out a little bit better for me. But hey, you know what, method works for you. So let's solve these out. Let's see. I know that y equals 3x plus 11, so I'm going to take 3x plus 11 and substitute it into the second equation for y. So instead of x plus y equals 3, I have x plus 3x plus 11 equals 3. Combine like terms, we get 4x plus 11 equals 3. Subtract 11, I'm being sloppy. No excuse for that. Okay, so we subtract 11 from both sides. 3 minus 11 is negative 8. And we divide both sides by 4. We get x to equal negative 2. Now that we know that x equals negative 2, let's plug that back into this first equation. So y equals 3 times negative 2 plus 11. 3 times negative 2 is negative 6. Negative 6 plus 11 is 5. It's a value of y. So a solution for the first system there is x is negative 2, y is 5. We write it as a coordinate, negative 2, 5. Let's see, same thing with this next one. We know y equals 2x plus 3, so let's plug that in there. We just got to be careful of our signs. So instead of x minus y, we have x minus 2x plus 3 equals negative 4. I'm going to distribute that negative so I make sure I don't mess up my signs. X minus 2x is negative x, so negative x minus 3 equals negative 4. Let's add 3 to both sides. Negative x equals negative 1, so x equals 1. Now we're going to plug that back into our equation here for y. So 2 times 1 plus 3, which is 2 plus 3, which means y equals 5. So our solution for this second system is x is 1 and y is 5, or as a coordinate 1, 5. So these are both solved using substitution. Since I had one variable set up as equals, y equals, I took whatever that was for y and plugged that in and substituted it into the second equation. That allowed me to have one equation, one unknown, which I could solve for. Once I found that value, in both of these cases it was x, I could simply plug that x back into either one of those equations. It doesn't matter, it's take your pick. I used the first one because it was already set up as y equals, that's what you're trying to find. So once you get your x and y, okay, what do we got next? Let's see what they can throw at us. Okay. Looks like we got a different method we can use for these. I'm going to use what's called linear combination. In that I'm going to combine these two equations together. And that's so fast, my friend. We need to make these opposite of one another. Right? I can't just add these together and expect magic to happen. I'm not a math teacher. So, we're going to... Wait, I am a math teacher. I'm not a magician. Yeah. Anyways, okay, so we're going to add these together, but I'm going to make one of these negative first because I want these x's to cancel out. Now I could choose the first equation and multiply that by negative 1. I just choose the second one because whatever. So we have x plus 2y equals 16. When we distribute this negative, you can't just change the variable you want. You got to multiply through everything by that negative. So it becomes negative x minus y equals negative 2. Please make sure you do that. These cancel out. X minus x, gone. I need like sound effect buttons. That'd be cool. Okay, anyways. So 2y minus y becomes 1y, and 16 minus 2 is 14. So y has a value of 14. Now we got to plug that back into one of those equations, and we plug it into the second one, so we can figure out what the value of x is. So x plus 14 equals 2, subtract 14 from both sides, we get negative 12. So our solution is when x is negative 12 and y is 14. Okay, the next one here, Well, we get to choose again which variable we want to eliminate. So whichever one you don't like. I am going to choose to eliminate y. Why, you ask? Why ask why? You can eliminate y. Okay, so let's get rid of y. So we need to make these the same. They're already opposite signs, right? We have a positive sign, we have a negative sign. All we need to do is make them be numerically the same. So the least common multiple of 3 and 4 is 12. So I'm going to multiply this entire equation by 4 and this entire equation by 3. So remember, we got to multiply everything in that equation by it. So we get 8x plus 12y equals 40. And here we have 9x minus 12y, which is good, that's what we want, equals negative 6. So these cancel out. We have 8x plus 9x. By the way, that's the actual sound that math makes when things cancel out. You usually can't hear it, it's so below our level of hearing, but that's the actual sound that is made when variables cancel out. Only math teachers, we're very specifically trained to be able to hear those types of things. So we have 8x plus 9x, which is 17x, equals 34. Well, that works out convenient because when we divide both sides by 34, we get x to equal 2. Let's plug it back in. Pick an equation, preferably an equation that's in the problem. So let's pick one of those and plug it back in. So let's plug in x there. So 2 times 2 now, plus 3y equals 10. So 4 plus 3y equals 10. Subtract 4 from both sides. 3y equals 6. Divide both sides by 3. And y equals 2. So our answer in terms of coordinate is 2, 2. Okay, if you have any questions or comments or to make fun of my bad jokes, feel free to leave a comment. Otherwise, you're welcome to like, subscribe, or share to our geometry videos.